Can you hear me?
Good evening, sir.
Yeah, good evening.
So,
Yes, sir.
30 participants joined so far. Okay. So myself, Dr. Balaprakash Rao, working as an assistant professor at NIT Warangal in the Department of Computer Science. So I don't know in the last 2 days whether you worked with Jupyter or Google Colab.
Google Collab, sir.
Okay, then
Google.
good one. Then all of you please open Google Colab. Open a new notebook. Let me open new notebook. Only 33 out of 80 still joining. Okay. So the outline of today is in the first session we are going to discuss about this visualization in Python using a library called matplotlib. In the second session, the other resource person, Dr. Venkateshwar Rao, he will give a brief overview of machine learning algorithms, and then he will demonstrate about some algorithms in machine learning. So first we'll start with this visualization using matplotlib. So in Python, visualization can be done using multiple libraries. One of the libraries is this matplotlib. Basically, it was designed on top of MATLAB. MATLAB means it produces MATLAB kind of figures, plotting. That's why the name matplotlib was given to this library, matplotlib. It produces MATLAB kind of figures. Okay, so let us start without delay. Let me see the participants. 36 of the participants joined. Okay, let them join in the meantime. So we'll start. As you know, if you want to import some library, you can import using this import statement, right? So let us import this matplotlib using import matplotlib. So generally in our class now, in our discussion, so you know, right, this one is, this is an import statement, this is a keyword, this is the library name matplotlib, and then you can write import matplotlib as something mp. So this is the shortcut name. Instead of writing matplotlib every time, we can use this mp, right? So similarly, suppose if you want to, yeah, it is fine if you proceed with Jupyter, but sometimes it will create issues. I don't know whether that module is available in your Jupyter or not. If it is available, then you can proceed. If it is not available, you have to install that library. That is the issue with these IDs, local IDs. Is it okay, Kumari madam? Okay, so better to go with Google Colab so that it will not create any issues about these modules. Okay, so generally in this matplotlib, there is this submodule called matplotlib, submodule called pyplot. So this submodule supports many functions for plotting. So you can import this pyplot as like this, as you can use some name, any name. Let me give something MPL or PLT. General name they use is this PLT plot. Okay. So this is one way. The other way of importing this pyplot is from matplotlib import pyplot. Now you can use all the functions within pyplot as pyplot dot something. Okay, these are the different ways of importing. This will import only matplotlib library. This will import the submodule called pyplot from matplotlib, and you can, instead of writing this entire thing, you can write, so you can simply write PLT. And this style from matplotlib import pyplot, you can directly use all the functions within pyplot. Whichever way is convenient, you can use that one. Okay, let me use this one. This is the general common way of using. So let me post also in chat box. So let me run these two statements first. So you can okay. Now let us try to generate some figures. Okay, so we'll import this matplotlib. No need of importing again because I have already executed, but no issue. So let me generate some data and let me generate these figures. So for that I am generating some toy data. So first we will see how to generate figures from these toy data. Then we will see how to generate figures from some inbuilt data sets. So some libraries called sklearn, they support some inbuilt data sets. So we'll see how to generate these figures from these inbuilt data sets. So the same thing can be applied with your own customized data sets also. Similarly, in the end, we'll see how to generate figures using this pandas. Pandas library was already discussed, right? So using pandas directly from pandas data frame, how to plot figures. These things we'll see. So first let me generate some toy data. So as you know, NumPy was already covered. This function must have covered this linear linspace. What it will do, it will create evenly separated samples. So what do you mean by evenly separated samples? Let us say 0 and 10 means I want to generate evenly separated samples between 0 and 10. How many samples I want to generate? I want to generate 100 samples. So 100 evenly sampled, suppose let us say 10 evenly separated samples means what? 0 to 1, 1 sample, 1 to 2, 1 sample, 2 to 3, 1 sample, 3 to 4, 1 sample. Means the entire range will be divided into 10 bins. From each bin, exactly 1. That is what evenly separated. Okay. So here I want to generate, let us say 100 samples. So I have generated 100 samples. Okay. Now let us say y on y-axis, this is x coordinates. On y-axis, I wanted to compute sin x and I wanted to draw this sin x. Okay, x versus sin x. So this again, this numpy supports np.sin x. So let me import numpy also. Import numpy as np. This is the shortcut name. That's why I use directly np here. So now we have x and y. So let us generate this sin x graph using this matplotlib. So suppose if you want to generate, there are two different ways. First, let me tell you the basic way. The first basic way is this plot.figure. You call this command plot.figure. This will initialize the figure. Okay, let me run this at this point of time. So what it is giving, you see. What do you mean by initializing? So figure was initialized. This is the size 432 by 288 with 0 axis, means no x-axis, no y-axis. Okay. So you can save also. You can save here. Let us call it as figure. This is for initializing. Then let me add axis. How to add axis? Same plot.axes. You simply call this plot.axis. It will add axis. If you see, this is the output after adding this command. X and y axis were added. You can also save this as ax something, whatever name you can give, you can give. Now, if you want to plot the graph, then simply call ax dot plot. What are the parameters you have to pass? X and sin x. Sin x means what? It was saved in y. Let me pass x and y. Let me run. Can you see? We have generated a line graph between x and sin x. So let me post it. Are you able to generate or not? You please tell me. Are you able to produce this graph? Okay. Okay, now what is the next thing that you want to do after generating a graph? Mostly, suppose you have done some experiment, you have collected some data. Now we have plotted data. Then after that, what you want to save those figures so that you can use it in somewhere.
What
Somewhere
is the
this.
use of plot figure?
Which one? What is the use of?
Plot figure.
Here, it will initialize. You see, without this, you see. That's all. It will initialize some space for the figure. That's all. You see, a figure with this much size was initialized with 0 axis, no x-axis, no axis, no y-axis. Okay, first okay, if you have any doubts, it will be cleared. Wait for a moment, sir. Yeah, Roshan, we will cover that also. Yeah, wait for a few minutes. So then the next thing that you want to do is you want to save this figure. So if you want to save this figure, how you can save? You can save using this figure dot save figure. You call this command save figure. That's all. And you give some name. Let us say sine graph. I am giving a name sine graph dot png or jpg, whatever you want you can give. So the moment I have executed this command, you see here there is a box, this folder symbol. If you click this folder symbol, you can see the sine graph was here. Now you can click this sine graph. It will show what you have saved. This figure dot save figure. It was not saved this time. Sometimes it is working. Okay, let me see. So someone asked one question, what is the use of plot dot plot? So the other, this is one way of generating this figure we have generated, right? The other way of generating the same figure is instead of writing these two commands, three commands, one is for initializing the figure, one is for initializing the axis, then we are plotting. So no need of writing all these things. What we can do is we can, instead of writing all these commands, we can write simply plot dot plot. It will take care of everything, initializing figure, initializing axis, then plotting everything. What you have to plot, you have to pass x and y. Both are same, you see. Let me post this one also. Instead of writing three commands, we can do the same task with a single command. I have posted. Please go through that one also. This saving is not working. Get that save figure. Ax dot save figure. Figure dot save figure only. Okay. Here it was saving, but it was not showing. It was showing empty. Some issue was there. Yeah, now it is coming. Earlier it did not came. Can you see this one? This is the figure that I have generated. Okay. This one you see. This is the figure. You can download this figure and you can see. You can download also. You click here. You can download this figure. You can use wherever you want this figure. Is it okay? Are you able to save and see the figure? Because first time it was not showing anything. Okay. Please try saving the figure also. Saving and you can download and you can use also. You should be able to see that figure, same figure. You go here for your folders and then click on this one. You should be able to see that figure. If you are able to see, then you can download. Okay, so we have seen these two ways of plotting the figure using plot.plot, and the other way is using three commands: initializing the figure using plot.figure, initializing axis using plot.axis, then plotting the figure using ax.plot. So now, before going to the discussion of other kinds of graph, so what is this graph? This graph is called line graph. If you see here, because all the points were connected with line graph lines. It means what? All the points were connected by a line, so this is called line graph. We'll see different other kinds of graphs. Before going to other kinds of graphs, let me present some of the customizations that we can do for this figure. So I will discuss this customization only once. You can apply the same kind of customizations to all other kinds of figures. So suppose you wanted to change the color of this line. How you can do? You can do that one. You wanted to add some name here, x-axis. You want to give some name here, you can give. If you want to give some name here, you can give. If you want to add some legend, suppose there are multiple figures for there. If you want to give some legend, you can give legend. You want to change these ticks I don't want like this 0, 2, 4, 6, 8, 10. I want 0, 1, 2, 3, 4, 5, 6, 7 like that. If you want to tune that one, you can control those things also. So we'll see how to control all these things. So first let us start with color, line color. How to change this color? You simply go here. It supports many other options. You see, yeah, let me delete this one. You see, can you see the options? It is supported by this plot function. These are the options. You can read this one also. Okay, entire that one you can read. So let me give this attribute color. So for this color, we can give directly red. Let me give red. You see, it has produced red color. If you give blue, it will produce blue color. Whatever you want, you can give. There are other ways of giving this color also. Instead of writing red, you can give R. See? So no need of writing entire red. If you write R, it will work. But will it work with all colors? No. It will work with only RGB, CMY. Primary and secondary colors it will work. And the other color it will work is black. Only these 7 colors it will work. RGB, CMY and K. K means black. These 7 colors it will work. This is the other way of generating this one. So instead of like this, you can give a what if you it supports HTML colors also. If you have some HTML color code, you can give that color code here. It will work with like that also. So let me tell you other way of giving this color. Instead of this, I can give 0.7 like this value. So 0.7, I think I have to give in bracket. I think quotes maybe. Yeah, it is taking a string here. Color is 0.7. Yeah. You see, it was producing what this value 0.7 means. So this it will take values from 0 to 1. 0 means what? Black. 1 means what? White. So if the value is close to 1, then it will give shade of white. If the value is close to 0, then it will give shades of black. See, it is more black. That is the use of this one. So similarly, you can combine RGB values and you can produce your own color. How to produce your own color? Now here we have given only one value. That's why it has produced grayscale. But if you want to produce some your own color, you pass RGB values. Let us say 0.3, 0.3 comma 0.7 and 0.2. So you know, right, this is RGB concentration, this is red concentration, this is green, this is blue concentration. So it will produce some green shade because 0.7 is green is more, so it will produce some green shade, you see. So let me paste this one also. I think I have not pasted these things. Yeah, in Jupyter Notebook, it will be stored in your local folder. The folder in which you are working, it will be saved. Please check that folder. So I have posted this one, this color code. So instead of this, you can let me post this one also. So I have not posted here. I posted 2 different ways of producing colors. So I forgot to mention something here. While saving the figure, it also supports different options. Suppose you want to save the figure with different quality, that you can do with this option DPI. You can give DPI as 1200 density of pixels per inch, right? This you can give DPI option, it supports. You can try with this DPI option also, saving the figure with different qualities. Let me post this one also. I think okay, so Now we have seen colors. Now we'll see, I want to change the line style. So here what we generated is, we have generated this thick line. Instead of line, thick line, connected line, yeah, earlier 0.7 was, some question was there. 0.7 was for gray. Now how it became green? Okay, let me tell you this one. So here 0.7, where is this 0.7? Yeah, here 0.7 or 0.1, it is only one color. So generally in images, if the value is between 0 and 255, it is actually gray. Color image means you will have three values, one for red, one for green, one for blue. Three primary colors combined will give any color, right? So we have to pass concentration of RGB. Whereas if you pass only one value, then it will think that it will produce a grayscale combination of means it will produce a color between 0 and 1, means black and white. If it is close to 0, black shade. If it is close to 1, white shade. Whereas here, if you see here, this is the order RGB. The moment you change red to the moment you change red to 0.8 and this one to 0.1, it will produce red shade because red is more concentration. If we give both 0.8, then this is the color that we produced, some yellow shade. Is it okay? Now let us see how to produce different line styles. So let me remove this color option. There is an option called line style. This is an attribute. Line style, it supports different options. What is the question? Can we give values for only two colors? Two colors means what? I didn't get. Here RGB, this here I gave three values. RGB combination, you can produce any color. Or you can search in Google, you can get the HTML code, you can directly give the HTML code also, if you want to work with HTML codes. Is it okay? Here, these are three colors, RGB. Combination of RGB will produce any color. These are the primary colors. Only can we give, oh, no, you can give for B also. You give 0.8, what it will produce, you see? It will, if you give 0.8, 0.8, 0.8, then it will produce some combination, you see? It is giving some, this combination. Again, shade of white and black. You can change all the values. I'm changing only one thing because so that you can see it is the red shade or green shade or blue shade. That's why. If you give 0.1 here, let me see here, 0.1 here, 0.2 here, and 0.8 here. What it will produce? It will produce blue shade. You can change all the values. Now we'll see this one, line style. So this line style option supports many options. The line style can be dashed. Okay. So here every time it will produce x versus y sin x, right? So let me change this to x versus x plus 1. So let me produce different kinds of lines. Four different options it supports. Let me produce dashed, dotted, dash dot, and then one more option is solid. So first let us generate this one. Let me change these things because otherwise it will overlap. This is x plus 2. This is x plus 3. This is x plus 4. Let me produce this one. Can you see the line styles? Different 4 different line styles are produced. Okay, the solid I have not changed, right? Let me write here solid. Solid means default option is solid. Default line style is solid. Now can you see it was producing? This is solid. This is dots. This is combination of dash and dot. This is dash, only dashes. So let me share this code also. Is it okay, Diksha? You can change red, green, blue. Okay, yeah. Yeah, I have pasted. You can see. Now, the same thing can be done in other way also. Without writing all this solid dash dot, no need to write all this. You can give shortcut names. What is the shortcut option? If you give dash, it will understand it as a dashed. No, solid. If you give two dashes, it will understand it as dashes. If you give this column symbol, then it will think as dots. If you want combination of dash and dots, you can give like this, one dash and one dot. See, it has produced same lines. Instead of writing dash, dot, all this, we have given these shortcut notations. Shortcut. Yeah, Manas. Which one you want me to explain? Manas?
Sir, the x plus 1, x plus 2, x plus 3.
Okay, no, this is okay. This earlier I have printed x versus sin x, right? Now I am printing x versus y equals to x plus 1, y equals to x plus 2, y equals to x plus 3, and so on. This is y, that's all. Means if x is 1, y is 2. X is 2, y is 3. Means 1, 2, 2, 3, 3, 4, 4, 5, like that I am printing. That's why it was, you see this line, it was going, this loop. Is it okay? I wanted
Yes,
to
sir.
produce 4 different lines. That's why I gave this x plus 1, x plus 2, x plus 3, x plus 4. To show these 4 different styles, line styles. If we give everything x versus sin x, then it will overwrite, right? Yeah. I, I have posted, right? This one also, dash dots. Yeah, I have posted. Okay, now if you want to combine these things, line style and colors, then no need of giving this attribute name. You delete this attribute name. You simply combine both values. So if you give R here, red, G here, green, blue here, B. Let me give C or M, magenta. Let me give magenta, C, M, Y. Let me give C. Now you see it will produce line styles with different colors. These are the custom colors. We have given these customized colors. Otherwise it is producing, it is giving colors in some different order. Now I have changed and I have given my own colors. So you can combine line style with colors. You can write color equals to G and line style equals to dash. Like that also you can write, but we have combined. This is the shortcut notation. Okay, now we'll see some other customizations. We have seen this color and line style. That is okay, color and line style. So now what we see is, so what happens when you write two graphs? This also we have seen, right? In the same figure it was producing. Now we'll see how to produce, how to give some x label, y label, all these things we'll see. Let us say sin x. We can directly write sin x here, np dot sin x. Okay, now suppose if you want to give some x label, you call plot dot x label. There is this default function x label. You give some name x. If you want to give y label, call plot dot y label. Sin x. Okay, you want to give some name to the figure, plot dot title. You give some name x versus sin x. All these things you can do. Now you see it has produced this figure. This color we have specified color, and by default it will give solid, but we have specified solid. Now this is the x label, this is the y label, this is the title of the figure. This you can do using these attributes, these functions, X label, Y label, title, all this. All of you are able to produce this X label, Y label. Is it okay?
Sir.
Yeah. Okay.
So can you explain once again how to save this for this new plot? We have to name particularly what it's
Particularly?
particular naming of this plot. Like we have used your sign plot. How
Yeah.
to save this plot?
Okay, this one you want to.
Yeah.
Okay. So give some name here. You see, I don't know whether it will work or not. I think it should work. Some word will give sign graph 2 dot png. Figure dot save figure, it is not working. Plot dot save figure, we'll see. Yeah, wait. So let me put first, let me save it. Yeah, this way also we can save plot dot save figure. Can you see? Now if you go here, sign graph 2, that's all. That is the first way. If you use 3 commands, then we call using figure dot save figure. Now we can directly call using plot dot save figure. Okay, so let me post this code. Okay, now we'll go ahead. Okay, labels, we have given X labels, Y labels, right? Now, let us see how to produce these legend. Let me remove these colors. It will it will give default colors. Okay, yeah. Now let me, instead of sin X, let me draw cos X. 2 graphs I have generated. Let me call this sin cos X. This is X versus title. Oh, you can give whatever you want. Okay, X versus something. Okay, now if you want to, these labels, this, okay, let us delete all this. Now we have 2 figures here, right? Now I want to save a legend. So if you want to print produce a legend, you simply call legend and run it. You see, it was not producing anything because we have not given any label. We have to tell what is this one, what is this one. So for that, here we can add label equals to sin X. Similarly here, label equals to cos X. Let me call this one. Now plot.legend. Now can you see the legend here? Blue line, blue chart is for sine graph. This orange one is for cos. Are you able to produce this legend?
보다가 보라 보달라
Please mute yourself, sir. Not there. Any questions so far? Okay. Now, if you want to control the location of legend, suppose like some people say, I don't want here, I want left side, I want upper. Okay. So I want an upper center, upper right, all this. So you can control those things. So this legend supports this option location. It location, this supports different options. It supports upper or bottom, left or right, Similarly, center, you can give all these options. So let me give upper, center. Now you see it has produced at the upper center. Similarly, you can give upper right, bottom left, all this. So for this figure, bottom left is better. And it has produced at the best position. You can give bottom center, bottom right, all this you can give, you can play. These options you can give. Bottom is one option, center is one option. Bottom is one option, but left is one option. Like this. You see, these are the options. Oh, not bottom, lower actually. Bottom, there is no option called bottom. These are the options you see. Best means it will automatically produce this location, best location. Wherever is empty, it will produce there. Upper right, upper left, lower right, right, only right you can give. Center left, center right, lower center, upper center, center. So here let me change it to best. Otherwise, let me give best. The options you have seen since bottom it is, you see, this is the best location. By default, it is giving best only. Similarly, okay, suppose you have multiple figures. Now, let me say we have one more figure, let us say. X versus tan x, let us say. Now, how many we have? 3 we have, right? One is red, one is green, one is orange. Okay, 4 came. I have pasted 2 times something. Where is tan? Okay, this one. Let me delete this one. Let me call it tan x. Okay, now we see here the legend, it was producing vertically sin x, cos x, tan x. If you add one more, it will come here. Suppose if you want to play,
Agni,
yeah, hello, please mute yourself, sir. So if you want to, suppose as the number of graphs increases, this legend will grow in this direction, vertical direction. But if you don't want like that, let us say when the number of graphs are 4 or 6, you wanted to move some of these legends to some of these labels to next column. So you want 2 columns, 3 columns like that. So it supports an option called number of columns, and col stands for number of columns. You can say number of columns equals to 2. So the default is number of columns equals to 1. If you give number of columns equals to 2, see, this is the figure that was produced. Number of columns is 2. So you can control this number of columns. 1, 2, 3, you can produce anything. Is it okay so far? Any questions with these customizations? Now we are done with customizations. Now we'll move on to other kind of graphs.
In this, which one is x-axis and y-axis?
Where? Yeah, can you see now? If we want to print more than 3 frequencies, means what, you want 3D graph? Vasi? Okay then. No response. So let me go to other kind of graphs. So So far we have covered this line graph and different customizations that we can apply to this line graph. Now once again I am repeating that the same kind of customizations can be applied to all other graphs that we produce from now onwards. So therefore I will not discuss all these customizations again and again for all these different kinds of graphs. You can apply same kind of customizations to all other graphs also. Okay, now we'll see some other kind of graphs. So far what we have seen is this is a line graph. Now instead of line graph, suppose you wanted to produce some scatter plot. There is this different plot called scatter plot. So here what we have done, we have connected all the points using a line. We are not showing any points. So suppose if you wanted to only project the points on the graph, then that is called scatter plot, means scatter the points on the graph. Simply project the points on the plot. So how we can do that one. Let me generate the same data we have generated. Now let me give x dot x comma y, right? Now here you can give a point symbol. So it supports different point symbols. If you give O means O stands for circle. By default it is O. So I think the points are very high. That's why we are not able to see. Let me produce only 50 points. np.line x. Where is the error? Plot. Oh, x comma y. Let me give sin x. np.sin x. Right? Yeah, now it has produced. Can you see? This is called scatter plot. Only points were projected. They were not connected. So this is one way of generating this scatter plot. Now we'll see the other way of generating. So instead of using plot, this pie plot supports a function called scatter. You simply pass x and sin x. No need of passing this one also. No. If you see here, the default shape is circle only. So this is called plot.scatter. So these two functions supports scatter plot and plot.scatter. Now if we see this plot.scatter, just now we have seen this shape of the point, right? We have given circle and it has produced all circles. You can control the shape also. Instead of circle, if you want to give squares, give S. If you want to give diamonds, give D. So let us see first the squares. These are squares. Similarly, you can give diamonds. You can give this left. It will give what? These triangles facing left side. If you give greater than symbol, triangles facing right side. If you give this caret symbol, triangles facing upper side. Like this, you can produce all different kinds of shapes. So let me give this one also. This is for different shapes for the points. Now, so this plot, if you see here, we can combine this line graph and scatter plot also. How to combine? So the moment you say this one, this symbol option, it will project the points, right? So you combine this with your dash. Then what it will do? It will connect all these points. So it will produce line and scatter plot, combine line and scatter plot. It will project the points and then it will connect those points. You see, points were projected, then they were connected using this solid line. Can you see? Now you can control this line style also. You can give dashes also, dots also, all this. Let me paste this one also. So this is scatter plot. We have seen two different ways of generating this scatter plot, plot.scatter and plot.plot. In plot.plot, if you simply give the shape option, it will produce scatter plot. Whereas plt.plot.scatter, it will also produce scatter plot. And similarly, you can control the shape also. You can use circle, square, diamond, triangles, different kinds of triangles. All this we have seen. So now we'll see other kinds of graphs. So let us see how to produce histogram. So what is an histogram? Histogram will count the frequencies. Suppose you have some data. Let us say the data is from 0 to 10. So our data is from 0 to 10, right? Okay, np dot same. Let me use same one. Let me generate from 0 to 10. Let me 1000 samples. Is it 1000? 10,000 samples. Okay, 10,000 samples I have generated. Now, if you wanted to count how many samples are 0 and 1, how many samples are there between 1 and 2, how many samples are there between 3 and 5, like this, if you wanted to count, then histogram is the best option. So let us, so this is a 1D data. Now we'll count how many points are there between different intervals. So let us say plot.hist, call this function plot.hist, and simply give this x. X is the data. Now you see what it will produce. It will produce this histogram. So why it has not produced linearly spaced, linearly separated data. 1000 samples also it is not producing. Okay, so since these are evenly separated, that's why maybe it was not producing, because all bins, yeah, it is correct only. If you see here, the data that we generated is using this linearly separated data, and between 0 to 10. So by default, the plot.histogram, it will assume 10 bins, and it will count the frequency of each bin. So 0 to 1, how many? 1 to 10, 1 to 2, how many? 2 to 3, how many? But if you see it's linearly separated, the command itself says that it is evenly separated. So that means 0 to 1, the number of points in 0 to 1 is equivalent to number of points in 1 to 2, number of points in 2 to 3, and so on. That's why you see it was like a single bin instead of different bins. Suppose if you wanted to separate these pins, then there is an option called, first let me paste this one, and you see whether you are able to produce this one or not. You see first. So it was looking like we have produced a single bin, a single square or rectangle kind of shape we got. So now if you wanted to see different bins, then simply call this option is there, row width. Okay, give 0.9. Now can you see these are the actual bins? Actually the frequency of each bin is same. That's why it has produced like this. Now let us change the data so that you can appreciate this histogram. Instead of linearly separated data, let me generate random data. So np.random.random, and so random stands for rand, this is normally distributed data. The data was generated using normal distribution. That's all. So let me generate 1000 points. It will be between 0 and okay. Now we'll see without this option or with. You can see the difference in these bins. You see, in this bin these many points are there. In this bin these many points are there. Here more points are there because it was generated using normal distribution. So generally normal distribution with mean 0. That means more points will be around 0 and less points towards the tails, right? That is how normal distribution looks like. So that's why more points were generated at 0 and less points were generated at the tails. Now you give row width option. It looks nice. 0.9. Let me give 0.9. Now you see these are the different bins, and this y-axis stands for frequency of each bin. So from -2 to some point here, how many points were there? From here to here, how many points, like this. Random stands for normally distributed data. Points are generated from normal distribution. So are you able to produce? I have pasted. Are you able to? Okay. So now we'll see. So just now we have covered scatter plots, right? Again, we'll cover scatter plot. But this time, what we do is we play with different colors. You see here, what we got here, plot dot scatter somewhere here. All the points are of same size and of same shape, right? And if you want to change the size of these symbols, you see all the points are of same size, right? And same color. So instead of this, if you wanted to produce different points with different sizes and different colors, so that you can do using this scatter. Let me tell you that one, how to do. So we have seen this one, right? This will produce all the symbols with same shapes, same this one. Now, suppose you wanted to produce these symbols in different sizes. Okay, so that you can do. How you can do? First we'll see what we can do. First let us generate some different sizes. So I am generating different sizes. How many points are there? 50 points are there. So let me generate 50 different numbers between 0 and 1. Let me call it as S, or size. Let me call it as size. Okay, now this scatter option, this will take a list of sizes. So it will give, if you give S, there is this option S equals to size. You give S equals to size. Then you see what happens. If you see, all the points were very small, and we are not able to see any difference. It looks like same. Only thing is all the points were very small because all the values are between 0 and 1. So let me multiply this size with some 300. Then now all the points will be between 0 and 300. Now you see the size differences. You see size difference. Okay, there are many points. That is the problem. Let me produce only 10 points. Or let me generate the data. First of all, data let me generate randomly, so that it will not be in the same place. Now let me generate 50 points here. Let me generate y equals to same thing. I am generating random data instead of linearly separated data. I am generating x and y randomly, x coordinate, y coordinate. Now let me supply x and y here. So if we produce random data, then we can appreciate this one. You see now, the points are of different sizes. If you see this point, this size, this point big, this point big, this point small, and so on. So we have produced 50 different sizes. Okay, based on the value of the size. So it will take first point of x coordinate, first point of y coordinate, first point of size. So based on the first point of size, it will give the size, the different sizes, value in the size. Similarly, you can produce different colors also. How you can produce colors? Color equals to same np dot, let me generate some random 50 values. Okay, now it also supports this C equals to colors. You can pass list of colors. Now if you see here, we have given only values between 0 and 1, right? But it was giving some colors. Actually, earlier we discussed if the value is between 0 and 1, then it should give shades of what? Shades of black and white it should give, but it is giving default some colors. This is because there is an option called CMap, color map. By default, it will take a color map called VRIDIS. That is the issue. That is why it is producing these colors. So you can ignore these colors, CMap, no need to supply. Now the next question is, okay, these colors are simply values between 0 and 1. And it giving these different colors from this color map. So what is the color corresponding to each value? If you want to show that one, you simply call plot.color bar. What this plot.color bar will give you, you see what it will give you. It will give this mapping between value and color. If the value here, let us say here, let me call colors. You see, you want to see what is there in colors? These are the values in colors, 0.9, 0.3, 0.3, 0.25, 0.9, like this. Now, if you see color bar, 0.9 means it will produce this color. 0.6 means some color. 0.7 means somewhere here, this shade it will produce. 0.2 means this shade. 0.1 means blue shade. Like this it will produce. Is it clear, this one? So if we see here, different. Okay, yeah, let me see. So you are just typing rand instead of random. No, you can give rand also. Rand is random values. Random means normally distributed values. That's all. Okay, let me type random, then you see what happens. Let me see. Let me type random, then you see what will happen. Why it was not responding? Yeah. Let me type random instead of rand. What happens when you type random? It is normally distributed data means what? Normally distributed data means, just now I have discussed. So most of the points will be around 0, around mean. So by default, it will produce points with mean 0. So most of the points will be around 0. So if you see now, all the points will be around 0 and 0. Most of the points, not all the points. You see, most of the points were here, right? And most of the points here are, you see, all are big. That's why I have given rand, so that it will distribute those points around the, instead of one place, I wanted to distribute around the figure. That's why I used rand instead of random. That's all. That is the only difference. Is it okay? Instead of, sorry, if you want the color bar in red, green and blue instead of CMap. Okay. Okay, so this color map, it supports different color maps. Default, it is VIR IDIS. But if you see, if you search for these color maps, it will support different color maps. It supports blues, means all shades of blues it supports. These are the shades of blue. You see different shades of blue, 100 different shades of blues. If you give greens, it will produce different shades of greens. So there is a set of CMaps that you can give as input. You can play with those CMaps. You see, if you want to explore all possible CMaps, you please search for the CMaps option in plot.scatter. It will give you all possible options. Is it okay? That's okay. So the CMap options, it will support many different CMaps. Whichever CMap suits your purpose, you can use that one. So let me delete this one also, not required. I have pasted. Please go through it and produce. And tell me, are you able to generate or not? Okay, if you produce more points, then it will be thick, this graph. instead of 50, if you produce 100 points, then there will be more points in the graph. That's all. 50 or 100, it is up to you. I see I produced 100 points. That means, why did you say normally distributed means near to zero only? Near to zero means most of the points are near to mean. So by default, it will take mean value as 0. That's why if you see paint. So if you see the normal distribution curve, it looks like this one, as most of you are aware of this one. I'm drawing using a mouse, so this is not good. You can see. So this is mean. Around mean, more points will be populated around mean, right? So by default, the mean will be 0 in this case. Matplotlib plot dot scatter, not plot dot scatter, np dot random dot random. As I hope you know these things. So less points will be populated here, tiles. Only few points, let us say. Let us say this height defines the number of points. Then only few points will be populated at the tiles. More points will be populated at the mean. That's what I mean to say. Is it okay? Yeah. 0 means in this case, the scatter command, it will assume that the mean is 0. That's why more points will be around 0. You see here. Now that's why we are not using random, we are using rand. If you see here, the points were, now if you see here, the points were distributed across 0 and 1. Unlike the previous case, random. You can use random also, no issue. Okay, now we'll see. So this is a scatter plot with different sizes, different colors. So before this one, we were discussing about this histogram, right? In the histogram that we discussed just now is one-day histogram. We have generated some data, x coordinates, and we have counted the frequency of number of points within some interval. We have counted. That is what histogram. So let us count frequency in dimensions. Generate some 2D data, two-dimensional data. Let me generate. Since we are working with histogram, let me generate again normally distributed data. Yeah, some question. What is the difference between random and is normal? Random is not normally distributed. It is according to some random distribution. The default distribution used by Matplotlib, I am not aware, but it is different. The data it generates. Random stands for normally distributed data. It will produce samples from normal distribution. It is between 0 and 1. With mean 0, if you see here, the points are not between 0 and 1. Where I have used normally, yeah, this is, you see, normally distributed data. The points are not between 0 and 1. They are between -3 to +3, right? Whereas here the points are between 0 and 1. Okay, my voice is breaking. Sometimes, is it from beginning or just now it happened? Because now I got some issue that problems with connecting network. Just now. Now can you hear me? Is it okay? Now that my message on gone. Yeah, that yeah, now that pop-up was gone. Just now that message came that we are having trouble connecting the network, but that message was gone now. So I think it is good. So is it okay? Random. Rand means between 0 and 1 according to random distribution. Randomly it will what? It will generate those samples. Whereas random means according to the normal distribution, it will generate. So now Again, we'll see this two-dimensional histogram. Means what? We'll generate points in 2D. Let us generate normally distributed data in 2D, and we'll compute 2D histogram. So this 2D histogram is also known as sometimes heat map. So we'll see this one. So let us say you want to generate 2D data, that to normally distributed data. How you can generate? So this again np.random supports some function called multivariate. Multivariate normal distribution. See, according to this multivariate normal distribution means you can generate normal distribution data in higher dimensions, in 2 dimensions. So for this, what we have to, you see here, these are the options. One is mean. Mean is compulsory. Next one is covariance. Covariance matrix you have to supply. Then size, check valid, these are not important. Important means not compulsory, but these two are compulsory. Okay. So you have to give mean. Since we are generating 2-dimensional data, we have to give mean around first dimension, mean around second dimension. Let me give 0 and 0. Mean along first dimension is 0, mean along second dimension is 0. Then you have to give this covariance matrix. In 1D, we call it variance. In higher dimensions, we call it as covariance. So this covariance is not here. So let me give this covariance matrix as a list of lists. This is the variance across first dimension. Let me give some values 1 1 1 2 1 1 1 2. I have given. Now I have supplied mean and covariance. Now I have to tell how many points you want. Let me produce 1,000 samples, 10,000, whatever you want, 100 samples, whatever you want, you give. Let us see what it will produce. Can you see here? These are the points it has produced. Now let me see this.
So can you explain this again?
Yeah, okay. We are generating 2-dimensional data, and the data is generated using normal distribution. Okay, X and Y samples in this case. So I'm calling this multivariate normal distribution. This was not filling. So the first mean. Now earlier the command that we used is np.rand.randn. So that will produce data in 1 dimension, but now we are producing data in 2 dimensions. That's why this mean, you have to supply 2 values, mean along first dimension, mean along second dimension. That means what? Let me go here and tell. So here this is 1D data. Can you see here? This is the mean, right? 1D data means what? I have only generated X coordinates. That's all. Now what I am generating? X and Y coordinates. Means some point here like this. So now after plotting, you will see anyhow. So this first argument is mean along first dimension. This is mean along second dimension. Now in a higher dimensions, we use something known as covariance matrix. One who is not aware of this covariance matrix, please go through this one. So in 1 dimension, we use variance. In higher dimensions, we use something known as covariance matrix. So this is the covariance matrix along first dimension and covariance along second dimension. And these are the number of samples. And this is the data we have generated. If you see here, I have shown you the data. And the data, if you see here, how it has produced like this. You see, a list of lists, right? First list is it list of lists? Yeah, list of lists. Commas, separated by commas. That means these are list of lists, right? If you see X and Y, if you store this in X and Y, it will not store, because how many are there? there are so many, let us say 1000, right? 1000 points are there, but I want X and Y separately. So what I do is I transpose it. Okay. Let me transpose and let me store in X and Y. Now if you see X and Y, this is X, this is Y. According to normal distribution we have generated. Now we have this 2D data. Now if you wanted to draw this histogram for this 2D data, same plot dot hist2d function is there. Hist2d, you pass this X and Y. Okay. Let me run this one first. Can you see here? So you see, this is the mean along first dimension, 0. This is the mean along second dimension. You see, right? Now, just now I have described this color map, right? So similarly, by default, it uses again that VAR IDIS. Let me use color map and show you. Let me use color bar, plot dot color bar, then plot dot color bar. Why I am calling plot dot color bar, you will understand now. If you see here now this is Y coordinates, these are X coordinates. Now where we are showing the frequency? Can someone tell where is the frequency? Earlier this is the frequency in 1D. Frequencies were shown here. So this is clear. But now here, where are the frequencies? Z. Yeah, Z, there is no Z here. Frequencies are described using color.
The diagonal?
Yeah, you see here, here yellow means what? You see here, yellow means what? The number of points were more than 100, somewhere around 100 or 120. Since the data was generated using random normal distribution, most of the points were located here. Not most of the points. Many points were located here. You see, nearly 100, 120 points were located here. This 0 and 0. Similarly, you see here, this is green, dark green. Dark green means what? This is between 0 and 80 or 60 to 100. The points are between 60 to 80. So if you see here 0 to 0 are this place, this place, this place, this place, this place. Many points are located in this 4, 5. These squares. The square represents bin. Square represents bin. I will tell you how many points. So if it is yellow, that means it is 120 points, 110, 120 points. Is it okay, this one? Any doubts here? And earlier, I have not specified in histogram also. You can control the number of bins. So by default, number of bins will be 10. Here, if you want 20 bins, you can supply bins equals to 20. You see here, bins were 20. Can you see? So similarly here, you can control the number of bins. Not here, where? Here, plot the histogram. Bins equals to 20, you can give. Then the square size will decrease because the number of bins were more. You see, I have not executed, I think. You see, the square size has reduced, and now you can see there are more squares. Is it okay? This is bins. Similarly, you can control the color map. Instead of VIR, VAR IDIS, you can give blues also. Blues, reds. Let me give reds. There are many other. You see, this is red shades. Dark red means more points. Near to white means very less points. Let's paste this code. Rishi Krishna Das. So this is a single graph. So as it represents why I am describing these things. If you see here and this one, if you see this one, here we have 4-dimensional data: x coordinate, y coordinate, size, and color, right? And we are displaying everything in 2D only, using sizes and colors. Similarly, if we see here, the data is 3-dimensional: x coordinate, y coordinate, and we are counting the frequency of each coordinate, right? And then we are plotting this 3D data in 2D using these color bars and all these things, these ideas, color bar ideas. Okay, this heat histograms will be used in many fields of science and engineering when you are working with different experiments. So I didn't get you. Between two features means I didn't get. Brinda madam, Brinda Senthil Kumar. Between two features means, is this? Okay, data interpolation will be a bit difficult if we don't use legends. But here we have only one graph, right? What is the need of legend here? I didn't get you, Rishi Krishna Das.
Is this
Sir,
like heat?
actually,
Yeah, please.
sir, the colors are very like we cannot tell like which color is what, like how to interpret the data when we are working
Okay.
with like we are just telling that it will exist between these two, but
Okay,
by
okay,
seeing
okay.
with eyes how we can interpret when we work with a real data.
Oh, this is 50 I gave. Let me give 5. Now you see when the number of bins were less, can you see the difference?
Yes, sir.
Yeah. Since the number of bins I have given to 20, that's why it is difficult to visualize. But when the number of bins were less, then you can interpolate. It means you can find what is what. All this.
Sir, what are bins, sir?
Bins means number of bins means here you see. Yeah, let me go here. This is bins. That's all. We have divided all the points into 20 bins. Some interval to some interval. Let us say the points are between. So here it is random or normally distributed data. It is generating. Let us say earlier, if you are still confused, let me tell you here. Instead of normal random data, let me give linearly separated data. This I have shown you also. 100 points. 0 to 10. Okay. Now by default, let us say the number of bins were 10. That means what? 0 to 1, 1 bin, 1 to 2, 2, second bin, 2 to 3, third bin, 3 to 4, next bin, 4 to 5, next bin, and so on. 10 bins it will produce. Right? That's why, since it is linearly separated data, all the frequencies are same. Number of points in each bin is same. Now, if you increase it to 20, then what are the bins? It is from 0 to 0 0.5, 0.5 to 1, 1 to 2, 1 to 1.5, 1.5 to 2, and so on. Is it okay? Is it clear, bins? Is it clear?
Sir, but here the linear space is like 0, 10, and 100, right? So it should have 100. The difference should be of 100, right? Like each should contain 100.
No. 0 to 10, I am generating 100 points. This is starting one, this is ending one. You can change this one. You can give 10, 10 and 20. Between means I am generating points between 10 and 20. How many points? 100 points. If you see here, under 10 to 20 there. Is it okay? For
But where are the 100
separated
points here?
Yeah. Where the 100
Where
points.
are the
You see how
100
many bins
points
are
here?
there? Yeah, let me tell you. How many bins are there? I have given 20 bins. In each bin, how many are there? You see how many are there? 5 are there. 20 into 500. Okay, if you want to see where are these 100 points, you see X. You will simply print X. You can see already 100 points. These are the 100 points. You can count. This will be 100. You see, I've generated between 10 and 20. Now let me count how many are there between 10 and 11. 1, 2, 3, 4, 10 and 10.5. 5. Then 10.5 to 11. 1, 2, 3, 4, 5, and so on. Is it okay?
Yes, sir.
Yeah. Okay, it was not it was showing all 100 points, you see. Yeah. So that's what we mean the bin. So here in okay, some other questions. Can we use third axis instead of colors to visualize the data? Yes, we can use. So this matplotlib supports 3D visualization also. Tomorrow I will show you 3D visualization and one more library called Seaborn and other library called SymPy. Tomorrow we'll see this 3D visualization. Yes, we can do 3D visualization. It supports all kind of plots, surface plots, wide plots, different kind of plots it supports. I may not show all those plots, okay, but I will show how to use.
Sir, if you want, instead of bins, if you want points or something.
Okay. Now, okay, yeah. Hello?
Sir, instead of bins, if we want
Voice is
points or
breaking. I'm not getting. Please post in chat box. I'm not.
sir, instead of bins, if we want
Problems connecting
points.
to the network. This is the problem, I think. Yeah, please, can you please repeat the question? Just now, the noise was breaking from your side. Can you repeat it?
Sir, if instead of bins,
you hear
if we
me?
want points,
Hello?
instead of bins, if we want points, sir.
Points means I didn't get you.
Like points, dots, or something like that.
Can you please post in chat box, or can you please repeat the question? The full question. I didn't get what do you mean by points. Because here we are counting the frequency. Okay. Can you hear me? At least, can
Yes,
you hear
sir.
me? Okay, let me repeat. Well, let me go on. So now we'll see. In sometimes what we need is we need a figure in which we wanted to draw subplots, multiple plots. So this matplotlib supports that one also using a command known as subplot. So let us generate some subplots with this toy data only. Okay, let me remove all this. Let me generate okay any data. Let me Okay, sin x only let me generate. So it is good to use this data only for sin x. 100 points I have generated. Now, suppose you wanted to, in a same figure, you wanted to plot sin x, cos x, tan x like this, different figures, small figures. So what you can use is, you can use this plot dot subplot. Plot dot subplot. So for this, you have to provide the number of rows and number of columns in the figure. Number of rows and column means shortly you will get to know. Let us say 2, 2. That means number of rows and columns are 2, 2. That means in the figure, you can produce 4 subfigures in the same figure. So let us say the current figure number is 1. So these are the indexes. Total number of rows, total number of columns. This is the current figure number. Now, if you wanted to plot some plot, you draw it x versus sin x. Okay, now this is the first figure. Now, in the same way, if you wanted to draw other figures also, you draw it. You tell that this is the second figure. This is the second figure. This is cos x. This is third figure, let us say. This is tan x. Let me generate up to here. np dot sin x, let me give np dot sin x, np dot cos x, np dot tan x. So here I have to give 2, 2. Can you see here? Here we have produced 3 figures, sin, cos, and tan in the same figure. This is the same figure. You can save this entire figure as a single figure. You can save it also. Using figure.save figure, you can save plot.save figure. Similarly, if you want to change these things, you see what happens. Let me give 2 and 3. What will happen? What will happen when I give 2 and 3? 2 rows and 3 columns. That's all. You see, all the figures came in single line like this. Now you can save also, and you can do save figure. Let me call subplot.png. You can save and you can see all this. It was saved here in Google Colab. See, can you see here this subplot? It was saved as a single figure. That is the idea of subplots.
Sir, can we give spacing between the figures?
Here.
Yes, sir.
So spacing this plot.subplot, we have to see all the options. Plot.subplot option we have to see. I don't know what features it supports. Plot.subplot. I'm not aware of options for spacing the figures, but we have to explore this plot.subplot. It is not giving options. You please see the options of this plot.subplot, madam. Okay, so 2.1, let me get 2.3.1 again. Okay, 3.1. Please see the options for this one. So, okay, it is already 6:30. So in tomorrow session, we'll cover this 3D visualization, how to generate data using data sets, how to generate data using pandas, how to generate data figures using Seaborn package. This we'll see. In addition to these things, we'll also cover some libraries, SymPy library. This is a library for symbolic mathematics. Yeah, codes will be shared. The notebook will be shared with you. So we'll take 5 minutes break, 5 or 10 minutes break. Again, we'll start
Very good evening, one and all. So, am I audible clearly?
Yes, sir.
Shall we start?
Sure, sir.
Yeah. So, I'm Dr. Venkateshwara, Assistant Professor at NITW. So, my research interests include data mining and machine learning with a specific focus on recommender systems. So, in this session, I'm going to take Introduction to Machine Learning with Scikit-learn Library. So this is a series of sessions starting from. Is my voice echoing?
Your voice is echoing.
Eh, Okay, let me check. So is it fine now?
Yes, sir.
Okay, you're not getting echo, right?
Yes, sir.
Okay, so is it clearly audible now?
Yes, sir.
Okay.
Yes,
Thank
sir.
you very much. Okay, right. So is my screen visible to you all?
Yes, sir. Yes, sir.
Okay. So thank you. So let's start the session. So in this session, we're going to introduce the machine learning algorithms with scikit-learn library. Um, so as you all know, the modern life is web supporting, isn't it? So we rely on the internet for many things in our day-to-day life, isn't it? So we read news articles and books online. We purchase things online. We reserve cab online. We order food online, and we plan for tour online, as well as we engage in various other activities with the help of World Wide Web. And we can do most of our things with the help of World Wide Web, and we can do most of our regular things online. And this has made the internet become part of our life. So therefore, it is natural that the competition among the vendors offering various services and the customers' interaction with these systems, leading to the explosive growth of the data. So we are living in the data era where a huge amount of data has been collected and stored every day. So in the face of this growing quantity of the data, machine learning methods have become inescapable. So you may be using these machine learning algorithms dozens of times in a day without even knowing that they are the machine learning algorithms. So let's start with very simple example. Like for example, everyone everyone is familiar with YouTube, right? So when you see some YouTube video, it might some videos to you beside, isn't it? So YouTube uses the machine
Sir,
learning
your voice is
algorithm.
breaking, sir.
Sorry.
So your voice is continuously breaking.
My voice is breaking up. Is it?
No,
Sir,
what you spoke was clear, sir. But when you were giving a lecture, like it was up and down.
yes, sir. Sometimes it is echoing and sometimes it's clear. It's very difficult to interpret what you're saying.
Okay. Give me a minute. Sorry for the inconvenience. So, yeah, how is it? Is it better now?
Yes.
Okay, it's fine, right? No echo, nothing. Is it clear?
Yes, sir.
Okay, okay, fine. Sorry about that. All right, so was there really trouble or should I start from the beginning or it's okay? So the point
It's okay,
is,
sir.
yeah, all right. So the point is that we're currently living in a data era where the huge amount of data is collected and stored every day. So in the face of this growing quantity of the data, machine learning methods have become unavoidable. So maybe we may be using these machine learning algorithms dozens of times in a day without even noticing that the machine learning algorithm. Like for example, you take the YouTube. Every one of us may be watching YouTube. So when you watch some video in the YouTube, it may recommend some set of videos to you. So the YouTube uses the machine learning algorithm for this. So YouTube uses this machine learning algorithm to exploit the user's data and feedback to personalize the recommendations. So when I watch some video, I may get some set of recommendations. When you watch the same video, you may be getting different set of recommendations. So it is exploring the personal information to make the recommendations accordingly to each and individual persons. So when you like some video or when you skip some video, YouTube learns from that and make the recommendations based on your preferences. And this learning is continuous and recommendations evolve with your preferences to make your experience more enjoyable, right? So like this, you may be using the machine learning algorithms at many places. Like for example, when you're searching something in a Google, so when you type few words, it recommends the next word for you, isn't it? So there, Google uses the machine learning algorithms. Similarly, when Facebook suggests some tags for for your post, isn't it? So when you upload some video, it recognizes your friend, it recognizes your family members, it recognizes your face. So all this, the techniques behind all these are machine learning algorithms. So we may be using these machine learning algorithms at many places without even knowing that they're the machine learning algorithms. So let's proceed. So let's try to understand what is machine learning and what are the different types of machine learning and different problems in the machine learning and the solutions and the implementation of these machine learning algorithms using the scikit-learn library. So we'll start with what is learning, then we'll go for what is machine learning and different types of machine learning and different problems in each of these machine learning types, and we'll try to implement these machine learning algorithms using the scikit-learn library. So, so let's start and we'll implement some of the problems in today's session, and we'll implement some of the problems in coming sessions. Right. So this is the agenda. Right. So what is learning? First of all, what is learning? When do we say that we are learning something? So we say that we are learning something when our performance is improving with our experience, isn't it? So when do we say that we are learning cooking, or when do you say that you're learning dance, or when do you say that you're learning music? If somebody is appreciating my cooking, or if somebody is appreciating my dance, if somebody is appreciating my music, and my performance at that task is improving with my experience, then only I can claim that I'm learning that, isn't it? So whatever it is, whether it is a music, dance, or cooking, whatever it is, my performance at that task is improving with my experience, then only I can say that I'm learning something, isn't it? So the learning is equivalent to improving with experience at some tasks. So I hope all of you agree with me at this point, isn't it? So learning is equivalent to improving with experience at some tasks. And human has the ability to learn from the experience. Let's take a very simple example. Suppose you want to toss a paper to the dustbin. So at the first throw, you realize that force is more. So probably you should reduce the force to correctly toss the waste paper onto a dustbin. Right. At the second try, you may realize that it is almost there, but you need to improve the angle that you are throwing. Okay. So after 3 or 4 tries, you gradually improve and you learn to throw this waste paper to a dustbin correctly to the dustbin, isn't it? So at the first try, we're learning something and improving, and in the second try, we are learning something. Oh, I don't know what is the problem. Actually, internet signal is also good. Do you have the problem now also? Voice is breaking.
Your voice is breaking, sir.
I don't know what is the reason. Actually, internet connection is also good. I'm actually speaking loud. So let's see for 2 minutes. If the same problem continues, I'll exit and rejoin. Okay, so this sometimes it happens. It's a problem with the WebEx. So let's see for 2 more minutes, and if the problem still continues, I'll exit and join. All right. So please let me know after 2 minutes if you still face the problem. Please let me know. All right. Is that fine?
Yes, sir.
Yeah. All right. So we have the ability to learn from the experience. After the first try, after the second try, after the third try. So we are learning from the experience and improving at that task. Right. So can we make the machines learn from the experience? Okay, so is the question that I'm leaving at this slide. Okay, so what is machine learning then? Right, so learning is improving at some tasks. What is machine learning? If machines improve at some tasks, okay, with respect to some performance measure P and based on some experience C, then we say that machine learning. Right. So we're learning and machine learning. So machine learning means it is improving, machine is improving, machine is programmed to improve over some tasks with respect to some performance measure P and based on some experience E. So what is this TPE and how do we formulate a machine learning problem is the question now. Okay, so what are this TPE and how do we formulate a machine learning problem? So let's see a few examples to understand how do we formulate this machine learning problem. Like for example, if you take handwriting recognition problem. So the task here is to classify handwritten characters of words from the images. Right. And the performance measure here is the percentage of the characters of the words correctly classified. And experience here is the database of handwritten words with a given classification. Right. So we have this TPE and we say that machine learning at this task, handwriting recognition problem, if it is improving with respect to the classification, the percentage of words or characters it correctly classified. Okay, based on the experience that it is getting, based on the data that it is collecting. Right. And if you take the robot driving, the task is to driving on a public 4-lane highways using vision sensors. And the performance measure here is average distance traveled before an error occurs. And the experience here is the sequence of images and the steering commands recorded observing a human driver. So this is how we can formulate a machine learning problem with this setting, the task and performance measure and based on some experience E. Right. So we have seen what is learning and what is machine learning. Right. So what are the different, and we have also seen two different problems and how to formulate the machine learning problems. Right. So machine learning is an application of artificial intelligence that provides the systems provides the systems the ability to automatically learn and improve from the experience without being explicitly programmed. Okay, so underline these two things. It automatically learns and you need not explicitly program for that. Like take for example, hand written digits classification. How many digits we have? 0 to 9, 10 digits we have, right? So you need not explicitly program and say that if it is round in shape, then it is 0. You need not explicitly define a rule that if it is round and there is a straight line in the figure, then it is 9. So you need not explicitly program for that. You need not explicitly define the rules to learn something. It automatically learns from the data. So the primary aim is to allow the computers to learn automatically without human intervention or assistance and adjust the actions accordingly. So we explicitly, we do not code for it explicitly. It automatically learns from the data. So that's the beauty of the machine learning. So let us try to understand the difference between the classic approaches and the machine learning approaches. Let's say that we want to predict the price of the house based on 3 features of the house. Like for example, I have 3 features of the house that determines the house. I mean that describes the house, the size of the house, size of its garden, and the number of rooms it has. Right. So we have got these three features describe the house. Based on these 3 features, we should be able to determine what is the price of the house. The classic algorithms tries to define a relation between these features and the output variable that we want to predict, the price of the house, right? So it tries to fix the weightage that we give to each of these individual features. Like, for example, the size of the house may be given 1.2 weightage and the garden may be 0.7 weight and the number of rooms may be given 3.1 weightage. So like that, it fixes this the weight that it gives to the individual features and estimate the price of the house. So this is a classic approach. So the housing price formula, and it is explicitly coded. So we're explicitly defining that we give a weight of 1.2 to the size of the house, weight of 0.7 to the size of the garden, and weight of 3.1 to the number of rooms. Right. So explicitly defining, explicitly coding this rule. Right. If you take the machine learning approach, so it doesn't fix any of these weights. Instead, it automatically learns from the data. Right. So it models with unknown variables A, B, and C, and based on the available data, we determine this A, B, and C. Right. I'll give you a very simple example for this. Like for example, suppose assume that there is only one feature, just for the simplicity. Right. Just for the simplicity, assume that we have only one input variable, and we want to predict the size of the price of the house. Right. So size of the house is the input variable, and price is the output variable. Suppose I have a data like if it is 100 square feet, then it is $300. If it is 200 square feet, then it is $500. If it is 300 square feet, then it is $700. If it is 400, then it is $900. If it is 500, then it is $1,100. Right. So this data is given to us. Suppose I give a new instance. Let's say the size of the house is 600. What should be the price of the house based on this data? What should be the price of the house for 600? Can you see any relation between 1300? 1300, very good. So how did we get this 1300? How did we guess it? So we have observed this, the data given to us, isn't it? And we have estimated a relation between the output variable price and the input variable size. That means we say that price is equivalent to 2 times size of the house plus 100. Right. So like this, we have established the relation between them. So if the data changes, this 2 and 100 may change, isn't it? It's not fixed, right? So for this data, this is 2 and 100. If you take a different data, you might end up with a different values for this A and B. Let's say if it is A, if it is B, isn't it? So the machine learning approach automatically learns these variables from the data, right? So we have seen what is learning, what is machine learning, what is the difference between the classic approach and the machine learning approach. So now the question is, why do we need this machine learning? So why is it so much important? Because the data is the lifeblood of the business, and the data-driven decisions increasingly making the difference between keeping up with the competition or falling further behind. So there is a lot of difference between the machine learning based decisions versus non-machine learning approaches. Right? So the machine learning based decisions keeping your business ahead of the competition. Right? So data-driven decisions, sorry. So the machine learning can act as a key to unlock the value of this corporate and the customer data and enact the decisions that keep a company ahead of the competition. Right. And the machine learning has got lots of applications in almost in every domain, including manufacturing, retail, healthcare and life sciences, travel and hospitality, financial services, energy, and in almost every domain, the machine learning has got applications. So that is why the machine learning is important. And there are different types of machine learning. Supervised, unsupervised, reinforcement learning are the main types of machine learning algorithms. There is also semi-supervised learning, right? So, which is a combination of both supervised and unsupervised, right? So let's see individually each of these machine learning types. So what is supervised learning? What is unsupervised learning? And what is reinforcement learning? And different problems under each of these heads. Like for example, if you take supervised learning, there are mainly two types of problems in this. regression problem, and classification problem. We're going to see each one of these with examples and with some of the algorithms in each one of them. And similarly, in unsupervised learning, clustering, dimensionality reduction, rule-based learning, right? So there are different learning algorithms are there in unsupervised learning, right? And reinforcement learning is mostly used for the games or the real-time, to take real-time decisions, or for robot navigation, learning tasks, or to acquire the skills. So the different applications of reinforcement learning exist. We'll see each one of them with examples and different algorithms in which one of them. Before that, let us see the scikit-learn library. Let's try to understand this. Right. So, because if you observe the title, machine learning algorithms using the scikit-learn library. So, we are trying to implement this machine learning algorithm using scikit-learn library. So, what is the scikit-learn? It is a library in Python, right? Used for the used to implement the machine learning algorithms. It is very simple and efficient for predictive data analysis, and it is accessible to everyone and reusable in various contexts. And it is built on top of NumPy, SciPy, and Matplotlib. I think all three of these libraries you've already explored. So the scikit-learn library is built on top of these libraries, NumPy, SciPy, and Matplotlib. It's open source and commercially usable. So if you want to see the stable version, you can see it here. So I'm just clicking on it. So you can see the different problems, classification tasks, regression tasks, and different algorithms in each one of them with examples it is given. Clustering, dimensional prediction. These are the different modules of this library, right? So, and in which one of them, the different algorithms are listed out here. So you can see the different algorithms available in each one of them, and with examples also it is written. So if you have any doubt with respect to some particular model, you can come here and see the syntax of that model. Like for example, if you see this lesson, right? So you can see that, right? It is with example, it is given here, right? So it is very easy. Right, I'll show you with example. I'll come back to it. And these are the installation instructions. I'll share this. There's a question in the chat box. I'll come to it. So installation instructions are here. So you can follow these installation instructions and install this library. Right. What is predictive data analysis? So it is kind of prediction. Like we are predicting the price of the house, or we can predict to which class a particular instance belongs to. Or like, for example, if you take an email, to which folder it should belong to. Should it go to primary folder, or should it go to social folder, or should it go to updates folder, or should it go to forums folder? Right? It's a kind of classification, right? But similarly, if you take handwritten visit, image of a handwritten character. So what it is it A or B or C, or you're predicting it, right? And you're analyzing the data for that. So that is why it is predictive data analysis. Is that clear, sir? I don't know. I did not see. Sorry. Yeah. Comments. Right. So let us proceed and see different learning algorithms one by one. Right. So we have said that there are different types of machine learning algorithms. Supervised, unsupervised, reinforcement learning are the main types of machine learning algorithms. So let's start with supervised learning. So in case of supervised learning, we have input variables and the output variables. It means each instance is labeled, right? So, and a supervised model, if you are using Google Colab, you need not install scikit-learn library. It is already there. You can directly use it, right? If you are using Jupyter Notebook kind of tool, then you need to install that in your local system to use it, right? If you use a Google Colab, it is already there. You can directly use it. You did not install it. Okay, so A supervised model is trained on the label dataset composed of examples of the pairs like features and the labels. Like we have seen one example, no? House price prediction. So we have got the features and the corresponding target label or target value. So the price is the label and features are the size of the house, size of the garden, number of rooms. All these are the different features that describe the instance. So we have got the input features and the corresponding value. We call them as the input variables. All these features together, we call them as the input variables. And the target value, we call it as the output variable. And the supervised learning models try to learn a relationship between the input variables and the output variable. So it tries to learn a model that finds the relationship between the features and the corresponding label. So the label is expressed in terms of the input features, right? So the label is a combination of, is a function of the input variables or the features. There are two main types of problems in the supervised learning. One is regression model, another one is the classification model. So the only difference between these two models is that what kind of value that the output variable takes. Like for example, house price prediction. What is the kind of value that the output variable is taking here? Numerical value, isn't it? Price of the house is numerical value. It is a continuous value. It can be anything, right? It can be $20.34. It can be $100.43. Cannot restrict them to say that it should be $500 and $1,000, $1,500, something like that, isn't it? So it cannot be like that, right? It can be any value. Similarly, if you take weight of a person, suppose if you want to predict the weight of a person based on the height, so weight is also a continuous value. It can take any value, right? It can take 70.34 value. It can take 80.23 value. Any value it can take. So if the target value is continuous, then we call it as a regression problem. If the target value is a categorical means it is from the some finite number of values. Like for example, if you take what should be the output of the dice? If you throw a dice, what should be the output value? It can be either 1 or 2 or 3 or 4 or 5 or 6. It cannot be 2.5, it cannot be 3.2, something like that. It is from the finite number of values, 1 to 6. Right? So that is a class level. Similarly, to whether an email is a spam or not. So one of the two values that it is taking, spam or not spam, or whether the patient has a cancer or not. So one of the two values that the label is taking, yes or no, right? Similarly, to which folder the email should belong to. Primary folder, social folder, updates folder, forums folder. One of the four values that it is taking. Right. So what should be, what is the object? If you're recognizing object, is it a car? Is it a ball? Or is it a duck? Right? Or is it a hen? So one of the limited number of the values it is taking, the target value. Then we call it as a classification problem. So in case of regression model, we have given input variables and the corresponding output variable, but the output variable takes a continuous value. In the case of classification problem also, it is saying you are given input variables, that means the features, and the corresponding target variable or the output variable, but here the output variable is a categorical value. Right. So that is the difference between the regression problem and the classification problem. Right. Supervised learning, to summarize, supervised learning is applications in which the data comprises examples of the input variables along with their corresponding target values or the vectors. And in case of supervised learning algorithm, we try to model a relationship between the target function or the output variable and the input variable, input features, such that we can predict the output value for the new data based on this relationship. So once you model the data, once you express the relationship between the input and the output variable, when a new instance comes in, you can use that function to predict for the new data. Right. So to define the problem more formally, we are given a random set of weights, x1, y1, x2, y2, so on, xn, yn, where xi is the feature vector and yi is the corresponding target variable. Right. So xi is the feature vector, features, and yi is the target variable. Right. So given this data, the task is to predict for the new instance. So this information is given for the n instances, x1 to n. Right. So given n plus 1th instance or n plus 2nd instance, n plus 3rd instance, you should be able to predict what is y for that. So we only know x values for the new instances. We don't know what is y. Right. To take a new house for which we only know what is the size of the house, what is the size of the garden or number of rooms in the house. This information we know. But what would be the price of the house? We do not know. We should be able to predict that. And as I have mentioned previously, there are two main types of supervised learning problems, regression and classification. Right, regression when the target value is continuous, and classification when the target value is discrete. And the list of common algorithms in this is neighbor-based decision trees, regression, linear regression, polynomial regression, support vector missions, logistic regression, neural networks. So all these are the examples, different common algorithms in the supervised learning. Right. So let's see both these problems, regression and classification, one by one. But before that, if you have any queries, I can take. Any queries? Are you with me so far? Following me? Okay. Yeah, it is about the predictions and finding the patterns in the data and summarize the data and making use of this data to take some decisions, important decisions. These are comes under machine learning. Naman Nagarwal.
Excuse me, sir.
Yes, yes.
Sir, if there is something new information and previous experience is not available, so then machine learning will come into play or not?
Can you elaborate?
Sir, like we are basing all our
I'll give a very technical structure to whatever that you mentioned. So suppose the new data comes from the different distribution other than what you have modeled. Okay, so then will that work or not? Isn't that's what your question, right?
no, sir. Like I'm saying that there is no previous experience regarding our data. Then how will it predict?
If
Like,
no experience, then you may not be able to learn it. You may have to use some default model.
okay, okay, thank you.
Yeah. So there is a question in the chat box. For the problems shown, can we tell is it a regression or classification and how? Yeah, we can tell them. Like I mentioned, if the target, the value that you're trying to predict, if it is a continuous value, then you call it as a regression problem. If the value that you're gonna predict is some discrete value, like it means one of the labels from the predefined set of classes, right? Then we call it as a classification problem. Sorry, Dharmendra sir, is that clear?
Yes, sir. So
Sir,
I
here
understand,
we try
understand that point. But since we do not have these y1, y2, I mean the target values. So as of now, we cannot.
We have them. This is training data given to us. Y1, y2, yn we have. We don't have yn plus 1. We have to predict that. So this information is given for m instances. So observing these m instances, you have to determine a model, and based on that model, you have to predict for the future instances.
Okay. So y1, y2, the target values are continuous. We don't know, right? Because we don't have
We
the
know
values
them.
right
We
now.
can see them and check We can
Okay.
observe them and see them. We know them.
Okay.
Yeah.
Got it. Yeah. Thank you.
Any other queries?
Sir, will you touch upon feature selection methods?
Yeah. But none of these in detail, but definitely dimensional reduction techniques we have in this. I'll explain this, Diksha madam. Training data and testing data. We have examples also. So any other query so far from the discussion that we have so far? All right. Okay. So let's proceed. So let's see each one of these problems, regression and classification problems in detail. So what is the regression problem? So we have given a training set of points, x1, y1, x2, y2, so on, xn, yn, or xn, yn, whatever it is, where xi is a feature vector, d-dimensional feature vector, and yi is a continuous target variable. So underline this continuous target variable because it's the regression problem. So the task is to predict for the new instance. So let's start with an example. So how do we predict for the housing prices? So we collect the data regarding housing prices and we analyze how they related to size in square feet, right? So let's assume that we have only one feature for now, but you can extend it to multiple features also. Just for simplicity, I'm taking one feature, that is size in square feet. All right. So this is how the data is looking like, as you can see in this figure. So given this data, a friend has a house of 750 square feet. How much can they be expected to get is the question. So this is a regression problem because we have given information about some around 12 houses, right? Size in square feet and what is the price of that house. And we have given a new instance, 13th house, right? For which we know the size of the house, 750 square feet. How much can they be expected to get? So can you model a relationship between this input variable size in square feet and the output variable price in dollars, right? So there are different solutions for this. Linear regression is one of the solutions. So in case of linear regression, output is modeled as a linear combination of the input variables. It means simply, in very simple words, if it is a two-dimensional space, then you're trying to model this relation as a line. You're trying to fit a line to the data. If it is a multi-dimensional space, then you're trying to fit a hyperplane to the data. So given this data, a friend has a house of 750 square feet. How much can they be expected to get? Suppose if you fit this straight line to this data, it means you're modeling this data as a straight line, right? So in that case, how much can they be expected to get for 750? So 750 means here. So 750, it is around $150,000, isn't it? So now the question is, there are many lines that are going through this data. So like this line is going through this data, this line is also going through this data, this line is also going through this data, this line is also going through data. The infinite number of possibilities for a line, to draw a line that is going through this data, right? So there are many lines possible. Now the question is, which is the best line? Question is, which is the best line, right? So which is the best line? Can I say this line is the best, or this line is the best, or this line is the best? You can draw many lines, right? Or this line is the best, right? Suppose this is the data, right? So I give you three lines. One is this line, one is this line, and another one is this line. So 1, 2, 3. Which line do you think is the best? Third one is the best. Why? Because it is estimating this correctly for all the instances, right? So it is estimating the actual value very closely, isn't it? So the predicted value is equivalent to the actual value in case of the third line. Whereas if you see, the difference between the prediction and the actual values is more in case of lines 1 and 2, isn't it? So it means what? The cost is very low. We call it as a cost or a loss in case of this third line. Whereas if you take the lines 1 and 2, the cost is high, right? Or the loss is high, isn't it? So which line is the best line? The line that minimizes the difference between the actual and the estimated prices is the best line, isn't it? So that's what we have seen, right? So our aim is to learn a line that minimizes the difference between the actual and the estimation prices. And a cost function let us figure out how to fit a best right line to our data. So for example, if you see this top right side corner figure, if you see that, so there are, if you see the line, when the line is either below the points or above the points, the cost is very high. But if you see when it is fitting to the data, the cost is very low. The cost is reduced when it is coming close to the data points. So I just want you to observe that, right? So, and I said the line that minimizes the difference between the actual and the estimated prices is the best line. And there are many lines possible that are going through this data. What makes the line different? What is the equation of the line? Some ax plus b, isn't it? Y equal to x plus b or mx plus c, isn't it? So isn't it in the form of theta naught plus theta 1 x, isn't it? Where theta naught equal to b and theta 1 equal to a, right? So what makes the line difference? These two parameters a and b, right? Or theta naught and theta 1. Right. So the two parameters, theta naught and theta 1, making the line different. And what is our objective? We have to, our objective is to choose these two parameters, theta naught and theta 1, such that the difference between the actual and the predicted values is low. Okay. So the prediction should be as much as close, as much, as close as possible to the original value. The prediction must be close to the ground truth for all over the training examples. So our goal is to learn the parameters theta naught and theta 1 such that the difference between the actual and the predicted values is minimized. Okay, so that's what the objective of this linear regression model. So it's trying to learn a line or the parameters of a line or a hyperplane, theta naught, theta 1, theta 2, and so on, such that the difference between the actual and the predicted values is minimized. Right. So let's try to implement that. And this can be extended to multiple input variables also. If x is size of the square feet, only one input variable, then your model is theta naught plus theta 1 x. Suppose, let's say that we have multiple input variables. Like for example, x1 is the size of the house and x2 is size of the garden and x3 is what is that? Number of rooms. Okay, so in that case, what is your model? Your model is a hyperplane. Your model is a hyperplane that is theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3. Okay, so if you take x naught equivalent to 1, then you can write this as theta naught x naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x2. Right. So right. So let's try to implement this and come back to the slides again. So I'm executing this in a Jupyter notebook, but if you're familiar with Google Colab, you can execute there also, no problem. So the first step is to import the libraries required. Okay, so I'm just importing all the libraries required. Right, so I'm importing NumPy library to do all the vectorized numerical computations. So I'm just importing NumPy as NP. And I'm also importing matplotlib to plot the graphs for better understanding of the problem at hand with some visual aid. I'm importing matplotlib.pyplot. This also you might have seen, right? Matplotlib.pyplot as just give some name plot ELT. Okay. So I'm also importing data sets required. So from sklearn.dataset, I'm importing Boston dataset. So this Boston dataset is Boston house price prediction dataset. So the same, similar to the example that we have discussed. But here, not just one feature, I think 13 features are there in this. The output variable is price of the house. So this is also from scikit-learn library, sklearn is scikit-learn. So if you search this scikit-learn.datasets, so the different datasets available. Some toy datasets are available. Right. So you can see this, right? Toy datasets, real world datasets, generated dataset, loading the other datasets. So this scikit-learn library has some datasets. It has some toy datasets to play with the problem at hand. It has some real world datasets if you seriously want to compare your method with the other methods. It has some synthetic datasets, and there are various other datasets also. So in toy dataset, we have load Boston dataset. You can see that it load and returns the Boston house price dataset. So it is a regression problem. Right. Similarly, if you take load iris, it is a iris dataset, iris flowers dataset, 3 classes, classification dataset it is. Right. So like this, we have different toy datasets. Out of them, I'm just using this toy dataset for regression problem, that is Boston house price prediction dataset. Okay. So this is sklearn.datasets is to load some toy datasets and to play around with our written code. And then I'm also importing time test split. So here I'll answer a question that earlier one of the person has asked. Let me import it. sklearn.model selection. I'm importing time test split. Time test split. Right. So earlier one person has asked a question that what is the difference between the training data and the testing data? So the actual data, the original data given to us is divided into two sets, training and testing. Why we need to divide? First of all, we divide the data so that we can assess the model's performance. So suppose I'm building a model. It means I'm trying to form a relationship between the output variable and the input variables. So I've got one model or a hypothesis, okay, that represents the data. Right. So how do you say that that model is good? How can we say that a particular model is good when this model is predicting correctly for the future instances, isn't it? If it is working well for the new instances, then only you can say that this model is good. Correct? But how do we know whether it is working correctly or not for new instances? Because for new instances, you don't have any value, the target value. You only have X value, isn't it? So you don't have any idea whether it will work correctly or not for the new instances. So for that reason, what we do is that we divide the data into training and testing. and we use only training data to build a model. And therefore, this test data is new to this model. And we know the ground truth for that. So we can compare the ground truth and the prediction values for the test data. And this test data is hidden from the model building. Okay. So because it is hidden from the model building, it is new to that model. So I want to assess how is it performing, how the model is performing on the new data. That is why we keep the test data separately. So that's the difference between the training and the testing data. So is that clear? Whoever has asked that. Okay, right. So this, so by the way, this train test split is to divide the data into training and testing data sets, right? So I've imported this also. Now the main function, I'm importing the linear regression model. So from sklearn.linear model, I'm importing linear regression. Linear regression. So this is a function or a linear regression model that I am importing. Another one is left, that is matrix. So to assess the model performance, based on some evaluation metrics, we evaluate the model's performance, isn't it? So all the different metrics are available in sklearn. Give me a second. So from sklearn.metrics, here different metrics are available. Metrics used in the classification tasks, metrics available in the classification tasks, regression tasks, in clustering. All these are available. You can check that. If you type sklearn.metrics, you can see the different metrics available here. Right. You can see that classification metrics. All these are for classification tasks: accuracy, balanced accuracy, top accuracy, F1. And these are for clustering, and these are for regression, right? So different metrics are available, and this is how you can execute access them. Metrics.max error, metrics.mean squared error, right? So so we are importing out of all these metrics, we're just importing what? MAE error, mean absolute error, which is the mean absolute difference between the actual and the estimated prices. I'm importing mean absolute error. So I'm just naming it as MAE. Okay. So I think that's all. If anything required, we'll import that time. So these are the different libraries that I require. Okay. So I'm just copy pasting this to you. So if you want to execute this, you can do it parallelly. Right. So the next task is, once I import this, next task is building a linear regression model. Right. So let me build a linear regression model. Okay. So for this, I require the data set, and I said that I'm loading a toy data set from sklearn library. What is this? Okay. So from sklearn library, I'm just building a linear regression model. So for this, I require a data set. So data set I'm taking from the sklearn datasets, Boston dataset I am taking. So I just have to call this function load Boston, which returns a dataset. Okay, so load Boston. So once I get, so this is to load the dataset. So once I get the dataset, I have to prepare this dataset in the required format. What is the required format in terms of the input variables and the output variables. So for this X and Y, I need to extract. So what is X? From the data set, I need to extract what is X. So from the data set, I'm just extracting X, which is the data, right? And also I'm extracting the target values. Data set dot target, if you call, it will return you the corresponding target values. So these two to prepare the data set. Prepare the data set in the required format. Right. Now I've got the data set in the required format. What next? I have to divide the data into training and testing. Right. So to divide the data into training and testing, I have the method called train test split. So which takes the data and divides the data into training and testing. Right. So I'm just taking the data set. Right. I'm calling that train test split. So what should be the argument for this? I need to pass X, I need to pass Y, and I also should specify what is the test size. So if I specify test size equivalent to some 0.3, it means what? I'm taking 30% of the data as the testing and the remaining 70% as the training. Okay, so this division is done randomly. So if you want to get the same results, just for the demonstration purpose, I'm fixing the random state, but this is optional. So if you fix the random state, everything, when you divide the data into training testing, it will, same division will happen. Okay, the same instances will come in the training and the same instances will come in the testing. But this is not necessary, because I'm just demonstrating. I just want to fix the random state. So this returns training and testing data. Training and testing data. So X train, Y train, and X test, Y test. So this returns train data and test data. Just keeping them in X train, Y train, Y train, Y test. Okay. Yeah, slightly random state, because the selection is random. If you change the random state, then the instances that comes to training and instances that comes to testing will change. Okay, because if there's a change in the data, then obviously there will be a change in the accuracy, but not so much. I'll explain you then. But let us finish this. Okay, so I've got now training and testing data. X train, X test, Y train, Y test. Okay, so this is to divide the data into training and test. Okay. So what next? Once we divide the data into training and testing, we have to train our model using the training data. We have to build the model using the training data. So what is the model that we are trying to build? Linear regression model. So let us call that. Okay. So linear regression model. So I'm just using LIN underscore RUG for this linear regression model. So I have already imported this model here. I'm just calling that linear regression model. Okay. So once I call the model, I have to fit it for the training data, isn't it? So I have this object. Using that, I feed it for the training data by calling a fit function. So X train, Y train. Right. So this completes the model building. Okay, what did I do? I imported the model, I just called the model and I fit it for the training data. So once I fit the model to the training data, what next? What next? I have to test it, I have to assess the model's performance, isn't it? So evaluate the model. So this can be done by calling a predict function on the test data. So I feed the model for the training data. I'm testing it for the predict test data. Predict test. So just observe here, for the fit function, I have passed both x train and y train. Whereas for the predict function, I'm just passing x test. So we have to get the corresponding y's. So I get y prediction here. Right. So once I get the y prediction, I know the actual value for this y test, and this is y prediction.
Sir,
So
R should be capital, sir.
okay, thanks. Right. So now, I want to assess the model's performance. So for that, I've imported this mean absolute error as MAE. So I need to pass MAE error is equivalent to MAE of y test and y predict. So this returns me the mean absolute difference between the y test and y prediction. I just want to print that. Right. So I'm just printing. Sorry. Right. So if you see 3.16 is the error. Okay. So this is how you can test your model, right? So if you don't, I'm now again executing, you can see the same thing you're getting, right? Same thing you're getting. Suppose if I don't fix the random state, means you may have a chance to get different divisions. So see the value changing now, 3.1, 3.4, 3.46, 3.38, 3.6, 3.5. So like that, if you execute it different times, you'll get different things. So there is a question in the chat box. Will the random state alters that? Yeah, it is. You have checked it, no? What is the range of ME? It depends on the problem. I mean, data set. Suppose if the target values are in the bigger range, the mean absolute error may be also in the bigger range. If it is in the smaller range, then MA is also in the smaller range. Right. Like for example, if you take one, price of a ship. Price of a ship is in a very big range, no? Okay, so suppose if it is in 10 crores, 10 crore or 20 crore or 100 crore. So when it is 100 crore, estimating closely means some 99.98 crores is fine, right? But in that case, the difference is around 20 lakh. Okay, but take the price of bottle, which is in the range of 100 to 200, probably 100 to 1000 at max. Okay, so in estimating closely, in that sense means a difference of 20 or 30, isn't it? So the difference there is 20 lakh, the difference here is 20 and 30. Still, you say that both of them are good predictions, isn't it? So the MA depends on the application and data set at hand. Test size means what is the test data size? It should be the 30% of the whole data, or 20% of the whole data, or 10% of the whole data. Understood, Karthik? Here we have given 0.3, it means 30% of the whole data we have taken as the. So explain the divide the data once again. So it is very simple. we divide the data into two parts, no? Training and testing. Training is to build a model, and test data is to assess the model's performance. Right. So to do that, we call this train test split. We pass x and y to it, and you also have to mention test size. What should be the percentage of the test data size? Should it be 30% or 20%? By default, if you don't specify anything, it is 20%. So, question from Diksha: what is the use of white train? White train is to build a model, right? So this is the observation. So we observe white train and build our model. So to model a relationship between x and y, we use white train, training data. By observing x train and y train, we build the model. We try to build a relationship between input and output. Is that clear, Diksha? Yeah. Any other query? Right. So yeah. So suppose if you want to visualize how the model looks like, let me generate some synthetic data set to show it to you. So I'm just making some linear data set. For this also I'm using scikit-learn library only. So I'm sklearn.datasets. So I said no, I can generate synthetic data sets. I'm importing make regression. So it generates a regression kind of data set. Right. So x1, y1 I'm taking. So I'm calling make regression. Sorry. Regression. And I need to pass the number of samples, how many number of samples that I want to generate. Let's say I generate 2000 samples. And the number of features that you want to generate. So just to show it to you, I'm generating one feature. And with what noise? What is the standard deviation or variance in the data? Noise, let's say I give some 5, 0.1, 0.3, anything that you can give. I just want to have more noise. So I give 5. I can give 15, more noise. Okay. So let's try to visualize this data, how it looks like. ELT dot scatter of x1 comma y. Okay. Data sets. Right. So this is how the data is looking like. Right. So if you reduce the noise, then this spread will be decreased. So like this. Okay. So I'm just taking more noise so that I'll have more spread out. Okay. So there is a question here. Yeah, we can plot y predict and y test to see the behaviors. So I'm just predicting for the whole data, you can see. So I'm calling the linear regression model. Model, right? What was the model? Okay, I just gave another model linear regression. Okay, let me give another linear regression. Let me call it again. What is there? Just to have a completeness. Linear regression model is, let me call this linear regression. A different option that it takes, but I'm not passing, I'm making it very simple. Okay. And I have to fit this, no? I have to call fit lr underscore model dot fit of x1 comma y1. Right. So now I have to predict for this, right? So I 1 underscore predict is equivalent to, can anyone tell me what should I call? What should I call? What should I call? No one? I should call predict, right? On x1. Right. So now I've got the predicted data. Y1 predict. So let me plot that. So how is it looking like? To see that plot dot, sorry, plot x1 and y1 predict. So I'm just predicting. I just want to use the red color for this, just to have a differentiation. So let's show that. So what's the problem? Plot is not defined. LT dot, okay, so PLT dot. Okay, so you can see this, right? So this is how the model is. So this is the prediction. So all along this red line is the prediction and these blue points are the actual values. Right. So this is how you can visualize this. Right. So now another point that I'm raising here, I said here that with each and every run, you may get a different MEA. Right, as you can observe, right? 3.63 you're getting once, 3.1 you're getting once. So it means what? A particular division may be biased to a particular model. So how you ensure a more robust results?
Using random seed.
Yeah, but you cannot fix it to particular random seed. Your results should be more robust, isn't it? So how about this? If I run the results for some sufficient number of times, and then take the average, is that fine?
Sir.
Yeah, then the variance will be averaged. Then you will have a more robust results. So that is one of the solutions, that you can run the same for some 100 runs or 200 runs and take the average MA. That is one possibility. The other one is the k-fold cross validation. So let me explain you. This is very standard one, better than that running 100 times or 200 times. So let me explain what is k-fold cross validation. Then we'll go for the code. So and then we'll wind up this session. Okay. Oh, I have already this. Okay. So in k-fold cross validation, we divide the whole data into k folds in k subsets. If I say k equal to 5-fold cross validation, then I divide the data into 5 parts, 5 subparts. Let's say 1, 2, 3, 4, 5 are the parts. And at each run, I'll take one of the fold as the test data and remaining 4 folds as the training data. Like for example, if you take this run, this run, I'm taking 2, 3, 4, 5 folds as the training data and fold 1 as the test data. Right. So I get MAE here. Let's say MAE 1. And in the second run, I take 1, 3, 4, 5 as the training and the second fold as the test data. So I get MAE 2. And I repeat the process. At last, I take MAE 3, I get MAE 4, I get, and finally MAE 5. Means 1, 2, 3, 4 in training and 5th fold in the test. I take average of all these individual MAEs to get the final MAE. Okay, so this is 5-fold cross validation. So this can be generalized to k folds for any value of k. Okay, so this is more standard. So how to implement this using the scikit-learn library is the question. So let's see that. Right. So very simple. From sklearn.model selection, I import cross validations. From sklearn dot from sklearn dot model selection, I'm importing cross validation score. Right. So, and my hypothesis here is hypothesis or a model. Let's take model. Why to introduce another to confuse you? Hypothesis and model are same. Model is linear regression. Regression. And now, so I just call class validation by passing the underlying model as the linear regression. Okay, and I get the scores. Okay, so the scores is equivalent to cross validation score, which I have imported, and the underlying model or the hypothesis is this model, which is the linear regression. And I also have to pass this data, let's say x1 and y1, and number of volts also you have to give. CV equal to 5 means you are saying 5-fold cross validation. And you, by default, the scoring is accuracy, I think. But if you want to give the scoring function also, you can give scoring is equivalent to, like, let's say, take mean absolute error. Okay, so this returns the scores or the errors from the individual folds, right? 5 times it returns, so it gives 5-fold, 5 errors. So let me print that scores and just print it. This is how they're looking like, right? So you can take negative of them to get the more absolute values. All right. So now if you just, you can take scores dot mean to get the final score. Right. So, right. So this is how you can do cross validation. The alternatives for this are, let me tell you, you can have a k-fold is another alternative. K-fold, repeated k-fold, shuffle split, repeated k-fold, shuffle split are some of the alternatives for this. Alternative functions. They are also from sklearn.model selection. Right. So you can use any of them. You can read more about them. Right. So any queries so far I can take, otherwise we'll wind up the session for today. So any queries? So in this class, we have seen what is learning, what is machine learning, different types of machine learning, and that we are exploring the supervised learning problem, and that there are two main types, regression and classification. We have checked regression, and in regression, we have seen one of the solution for the regression problem, linear regression, which models the relation between the input and output variables as a linear as a linear model. So the output is expressed as a linear combination of the input variables, and that we have implemented using the scikit-learn library. Right? Yeah. So I'll share it in the chat box now, and later I'll share it in the WhatsApp group also. If anyone want to try, you can try this. Right. So any queries so far?
Can you tell this random state uses again?
Sorry, Dharmendra sir.
Can you tell this random state parameters uses again?
Scatter.
Random state, this parameters uses.
I didn't get you. Actually, your voice is breaking. I have heard random state and which parameters it is using, something like that.
No, sir. This random state we used, right? It's uses. Just
Random state. Okay, random state. If you fix a particular random state, then every time when you run the program, you get the same kind of split. Okay, so the division is fixed. I mean, what are the instances that comes to training and what are the instances that comes to test is fixed for that particular state. Okay, suppose if you want to demonstrate the results, or for example, if you want to compare the two different algorithms using the same kind of division, then you can fix the random state in both the algorithms. Then you will get the same training and testing at both the places. So therefore, you can compare it. That is one possibility. So fixing the random state to get the same kind of training test split at every run. It is used for the demonstration purpose also. Is that clear, sir?
yes, sir.
Yeah. So question from Diksha: housing prices are positive numbers. Why we have? No, it is not negative mean absolute error. Mean absolute error means it is a mean absolute error only. But sometimes we get the negative numbers. I think this must be a bug in the somewhere. So then you can take minus value of that. So if you let me show you that mean absolute error in scikit-learn. You can see that regression, right? See, so this is neg mean absolute error. Where is it? Neg mean absolute error. So it is a mean absolute error. Yeah.
How do you decide the number of splits, cross-validation splits?
Brinda ma'am, number of splits usually there is usually people fix it to 5 or 10, but there is no hard and fixed rule that you have to fix it to 5 or 10. Only thing that you need to ensure is that the intuition behind this training and testing shouldn't be violated. So actually, when you are dividing the data into training and testing, you should ensure that the sufficient number of examples you get in the testing part. Right? Like for example, if I have 100 instances, okay, so I cannot venture to give 50 instances for the test, isn't it? Because if I give 50 instances to the test, only 50 instances will be in the training, and therefore the learning may not be sufficient because very few examples, right? So if there is 100, maybe at the same time, if I give 1 or 2 instances for the test, remaining 98, training may be good, but testing you cannot justify based on 1 or 2 instances. So you should give sufficient number of examples in the testing. Let's say 20. Similarly, if you take 1000, maybe around 200 you can give. Okay, suppose if we have 1 crore of instances, 20% of them is what? 20 lakh, isn't it? So 20 lakh instances you don't need for the testing actually, isn't it? So when the data set size is high, maybe 1 or 2% is also sufficient. 1 crore means just 1% of them, then 1 lakh number of instances you would get. That is sufficient enough. to test the performance of a model. If the data set size is high, then 1 or 2% of the test size is also okay. If the data set size is moderate, then you may have to go for 10% or 20% of the test data. Right. So now question coming back to your question that what should be the k value? So essentially what it is determining, if you take k value equal to 10, every time you are taking 10% of the data as the test. Okay. So based on your test set size, you have to select the number of folds. That depends on your data size.
Okay.
Yeah.
Normally for this biological data sets, like when they are sampling for this lifestyle data, we don't get enough data, sir. In that case, we can have like the splits can be 5, right, sir?
Yeah, yes.
Yes.
Any other query? All right. If no query, we'll wind up the session. Thank you very much. Happy learning and good night.